Now that you have a general understanding of Alfred Wegener's idea of continental drift and his notion that the continents move, we're going to take this a step further and determine how we know what the Earth looked like throughout its history. This is known as paleogeographic reconstruction. Quick review: Alfred Wegener's model of continental drift entailed the idea that the continents move. He had 4 pieces of evidence that you can see at the bottom here: matching coastlines, matching fossils, matching bedrock, and the idea that glacial striations match up when you put Pangea back together. Plate tectonics is different. Plate tectonics not only deals with the movement of continental crust, but it also entails all physical features and phenomena of the Earth, including earthquakes and volcanoes. Now, to construct or reconstruct what the Earth looked like throughout its history, we're going to be looking at fossil evidence and glacier evidence. An example of fossils being used to reconstruct Earth's history is shown here. This is a completely hypothetical example, but I believe it does a great job getting across the notion that we can use fossils to determine location of continents throughout history. The key thing to remember: organisms live in very specific environments. If the environment changes or they move outside that environment, they simply perish. So, the example I have here is very hypothetical. Assuming we find a polar bear fossil in South America, dated 60 million years ago, we know that there's no way this polar bear survived in this location, at this latitude. We know that it either had to be further south, near this pole 60 million years ago, or further north, near the North Pole 60 million years ago. Again, using the fossils to determine the location of the continents. Coral is another great use, or fossil to use, for organizing and determining the location of continents throughout history. Fossil coral, or coral reefs, only live within 25 degrees north and south of the equator. With this said, we can determine if a continent was located within those degrees if fossils are located in the bedrock. Wisconsin, for example, has fossil coral reefs located in its bedrock dated about 400 million years ago. That tells us that Wisconsin, 400 million years ago, was located between 25 degrees north and 25 degrees south of the equator. Glacial striations are scratches left on rocks by glaciers. Glaciers cannot move out of the oceans onto land. And just like the previous activity, Wegener vicariously, you determine that if we put continents back together, we avoid that problem. Now, for the lab you're going to be working on today, you will be dealing with 3 fictitious continents: Xanadu, Iota, and Zenda. And you'll be reconstructing what this world looked like over the course of 100 million years. I've provided you with fossil evidence. Each one of these is a distinct fossil or distinct organism. In addition, I tell you when they were alive and the latitudes they were located within. These could be either north or south. You will be constructing 4 maps, one for 100 million years ago, one for 75 million years ago, one for 50 million years ago, and one for 25 million years ago. You'll notice on the first map, the one you'll be working with, the continents are currently located over an outline. These outlines represent their location today. Step 1 is to determine where these continents were located 100 million years ago. I'll give you a hint. They were also a supercontinent at that time. So the first thing you should do is assemble this supercontinent the best you can by matching up the coastlines. When you do this, you'll notice a couple other things. The bedrock matches, as you see here, and there are arrows on these continents that represent glacial striations. If they were separated, it would look like the glacier was coming out of the ocean onto land. Now that we put them together, we avoid that problem. Once you've assembled your supercontinent, which I will not do for you here, you need to then determine the location of that supercontinent using fossils. To begin at 100 million years ago, we need to select fossils that were alive 100 million years ago. To do so, I'm simply going to look here at genus A and here at genus B. Both were alive 100 million years ago. 100 million is between these two numbers. So back on my continents, I'm going to look for any fossils that are A or B. Here you will notice a B, here's also a B, and here is a B. On this continent, Iota, you will notice that there are not any of the fossils we are looking for. However, on Zenda, there's an A located here and an A located here. I'm going to quickly group these together, just like we did previously. If I can get my pointer. Somewhere, there we go. I'm going to group this together. Whoops, moving the background here. Hold on. Lock this in place. If yours is not locked, you should do the same. I'm going to group this together, just like we did in Wegener Vicariously. And now I can move my continent so my fossils are located within the right latitudes. And we said A had to be between 45 and 60 degrees. So it has to be between this latitude and this latitude, which it now is. Again, for 100 million years ago, you will have a supercontinent, which I did not assemble here, that you'll be moving all together. You would do the same thing with the Bs. These Bs need to be located within 45 and 75 degrees latitude. So again, you would move these around till they're located within there. You may have to turn it a little bit, but the idea being, as you do this, you're going to reassemble the different maps. Once you finish the 100 million year map, the second map you make is going to be 75 million years. So now you choose fossils that were alive 75 million years ago. In this case, we can now choose B, again, because it's still alive 75 million years ago, A1, C, which is our coral within 25 degrees of the equator, and D, which is found 15 to 35 degrees from the equator. We no longer use A. A is no longer alive, so we do not need to be concerned with where it's located on the map. Once you have completed your 100 million year map, you are now going to break those continents apart from their supercontinent and move them in the direction of their current location. We know, again, their current location as those outlines. So you know that Xanadu needs to move in this direction. You know that Yoda is going to continue to move in this direction. Sorry, Zenda. You know Yoda will move in this direction. You simply use the fossils to fine-tune the locations of those continents. If you have any other questions, feel free to see me.